So today I will be talking about software, organizing software. So the first part is that this is basically a time when you can think about questions. This is more like more software engineering. The next part I think would be more interesting. For that I don't have slides. It's more discussion. So as a fun said, this is my more briefer version of my introduction. I work as a senior software engineer at Google. Before that, I did my PhD in computer science from University of Wisconsin Madison. And before that, I was a student at NUST. During my PhD, I was working mostly in network function virtualization, metal boxes, network function. That was my area. If you are interested in any of those topics, catch me after this talk. I would love to talk about those. Now at Google, I mostly work in the space of distributed storage system, caching. Those are my interests. Other than that, as Afan said, I like traveling. And if you want to talk about that, I'm also available. I was here a month ago when I was trying to convince him to join me on a trip to Ranikot and Mohenjo-daro, but he said no. What do I have? So there's a short disclaimer. This is all my opinion, nothing related to Google. Most of this talk is copied, inspired, or taken from other people I talked with, interacted, or have attended talks in Google, or based on what I have learned. So here, one interesting disclaimer is that by profession, I'm a software engineer. But by training, I'm an electronics engineer and a computer scientist. So there are things in software engineering which I learned after joining Google. Or maybe I knew about them theoretically, but I never used them. So this talk is about one of those things, which is like interfaces. So let me see, what do I have? But before that, in general, it's about organizing software. So one thing which was interesting when I joined Google was the way people look at the software. I was going from academia, where it's all about, especially when you're a PhD student, you want things to be fast. And that's your only goal. We don't care about whether the same code will work after a month or not. It has to produce results, and it needs to be fast. When I joined Google, so the biggest surprise for me was that they care about readability and code maintenance more than whether the code is fast or not. There will be times when, from my point of view, I have written a really optimized part of the code, which I can do in O of n. But the thing was that that's a complex code. And we don't need that complexity there. So a simple n log n would be fine if n is small. So those were the things which were really interesting for me when I joined Google. And with time, I started appreciating them more. And one of the reasons was that usually the lifespan of a code, or what's the expected lifespan of the code, it can vary from hour, days, week to decades. When you're in school, most of your code is on the left side, like hours or days, the life of your code. Or even if you're writing scripts, it's between that range. If you are working for a startup, maybe the lifespan of your code is somewhere between months to years. But for a company like Google or some project like Linux kernel, it's on this side, where the code lives there forever. Or at least you plan your code in such a way that it will live there forever. So for that, the organizing the software becomes really important, like how you are managing. The software engineering aspect becomes important. And so now, and this is my favorite quote about software engineering. I've copied it, but this is my favorite. The software engineering is like the programming integrated over time. It has that time aspect. So you can write a code which works, does the job, and it's perfect. But when you add the time dimension to it, it becomes software engineering. Because now you have to, even while writing or designing, you have to worry about like how I should structure that code that it can last longer. So this talk is about one aspect of that, of organizing software, which is interfaces. And I am pretty sure all of you have studied interfaces, used interfaces. And I will talk about a little bit about testing. So by interfaces in this talk, I mean the general concept. In some languages like Java, Go, there is a technical term like interface. But in this talk, I'm just talking about the general concept, which is a collection of methods without an associated implementation. And it's useful for there are two benefits of using interfaces. It helps you with physical code organization, and it also helps you with documentation. And I will try to show you or try to convince you how it will help you with both of them. And again, I want to clarify here, this is one of the ways to organize code. This is not the best way. People have different opinions. This is something which I liked in Google. Or I would not say in Google. Google is a really big organization. Every team has its own culture. In my team or the teams I interacted with, they use this a lot. So I liked it there. But I don't want to generalize it for Google. There are things which I will be talking about in this talk, like using mocks for testing. That is also something which is used in my team a lot, but we can't generalize this to all Google. There are people in Google who hate that or don't like that. And there are reasons for that. I might go over some of them. So yeah. So before I jump into the technical part, anybody has any question? So just to recap, here's an example of an interface. This is an example from standard Go library. We have a writer interface, which has a single method, write. It takes a set of bytes, and it writes them, returns the number of successfully written bytes, and an error in case of an error. Now, it doesn't matter. You can use this to write to an array. You can use this to write to a socket or a files. That doesn't matter. Similarly, even in C, we have something similar. So basically, here's another example of similar method where it is independent of the underlying implementation. It gives you this idea that, OK, this is what it does, and now you can have any implementation. And in most of the cases, your code should be like that. It should not be the abstract ideas should not be tied with the implementation. So now, coming back to interfaces. So when you're defining your interface, it should be a narrow interface. It should not have a lot of methods. It should not be a huge class with a lot of methods. It should be narrow, and those methods should be logically related with each other. What else? Again, and your interface should be semantic and app specific. For example, I have a service X, and I am building something in front of that. So I don't need to expose everything which service X is exposing. I should only expose what is related to my service. I don't need to think that, OK, service X is exporting this, I should also export this. No. You should design it like, okay, my service needs this. I should only expose those things, not what your full backend API is. And if later in time you realize that, okay, I need this extra feature, you can always go and modify your code. Instead of like exposing everything and then you don't know how other modification over that code will do with that code or how it will change, it's better to expose what is required and then go back and rewrite the code. Like, we should not be scared of rewriting our code. It takes time, and sometime your manager or team lead needs to be on board with that, but you should not be like scared of going back and writing your code. One more thing which I want to add about interfaces, like we give a lot of values to our APIs. Like whenever we're defining an API, we think a lot about them and we're like, okay, this is really important, and what should our APIs be? Interfaces are also really important. They are all your components in your code communicate through interfaces, or they should be communicating through interfaces. It modularizes your system. Okay, why do we need interfaces? One thing, so I will cover most of them or all of them in this talk, but just high level. It lets you isolate you from your dependencies. It allows you to write wrapper classes. It makes it easier to mock or add fakes for your testing. And it gives you a centralized place for understanding what your code does. If your whole code is based on interfaces, you just have to look at few places to get a high-level idea how your code works. So I will take an example of a simple application or a component, and I will use that to explain what I meant. So let's take an example of a geocoder. So what it does, it takes a street address and it calls a backend service, which let's say called GeoSearch, and it translates that address into latitude and longitude. In addition to that, it also calculates, it does something for billing based on number of transactions, and to improve performance, it does some caching. So that's what we're going to build, or like try to build the interfaces for this. So a simple interface for this would be a geocoder. It has an abstract method, which is translate, which takes location and it translates into coordinates and it returns error in case of an error. And that's it. It is not tied with any implementation. It's just at a high-level interface. Now, one anti-pattern which I want to highlight is don't put the word interface with your interface. Like it should not be geocoder interface. It should be geocoder.
And why?
It's clear from that it's a interface.
I mean, this is just not even joking. I mean, ridiculously, it's like an interface versus. There's an interface that could be also an object which is doing that. I'm just trying to see.
So the thing is like, yeah. So you can argue, but if you can go and look at the code, you know that's an interface. And everything which is implementing that is based on, the name is linked with that. So it's obvious that this one is implementing this interface. With that logic, will you put like the word class with every object? So it will help you with reading. It's a class. I don't need to go and look at like whether it's a struct or class. Any other question? Now, each class in your code should add one piece of functionality. It can implement the whole full contract, or you can have multiple classes to implement that. So let's take the example of our geocoder. In that case, we can have 3 classes, 3 implementation of that interface implementing our geocoder. We have a GeoSearch geocoder, which is responsible for talking with the backend. It will send an RPC, get a response, and that's it. We have a caching layer, which is responsible for caching the response. And then we have a billing, which is responsible for billing. And that's it. And we can now stack these on one on top of another one to implement our geocoder component. Some more anti-patterns. So don't put implementation with the name. It's like terrible name. Does it mean that you only have one implementation? Or if that's the case, then you have a really big, huge, complex class. And what if you want to change your implementation? Maybe you have only one implementation, and later you want to add more implementation. So that's not a good name. Now, one more thing about interfaces is that when you're using your interfaces, you should pass your dependencies to your interfaces. Like, for example, in the geocoder, the GeoSearch geocoder is taking an object of GeoSearch, and it will be calling that object to connect you with your backend. My caching layer is taking a cache, and it is taking a wrapped object, which will be my GeoSearch geocoder, and it will be using that. Now, the advantage of doing this is now if I want to change them, it's really easy. I can create them on different layers. The other the bigger advantage is that it makes my testing really easy. Now, if I want to test my GeoSearch geocoder, I can just inject a mock there or fake, and I can test that. I don't need to send RPCs to the real server. I can just test that part of the code. If I want to test the caching layer, the caching layer doesn't need to know what's on top of it, what's at bottom. The caching layer is only responsible of, OK, if this is the value I get, whether it caches that or not. And that's the only thing that layer is doing. I can test that. If I don't have this, without this, I have to, I can use dependency injection. There are libraries for C also, in C++ also, but they are slow. This is faster. But yeah, if you assume that you don't use that, you have to set up the whole thing, your geocoder. You have to send such requests so they can get cached, so I can test the particular behavior. In testing, one thing which is important is that, like, you should try to cover most of your code testing in unit test, because it's easier. You need less number of tests because you can test individual modules, and then you can have integration test. If you try to do testing at integration test level, the problem is that now if you have 2 functions, each of them has 3 options, now you need to test 9 options. It's exponential. Whereas if you are doing unit tests, you only have to test 3 here, 3 there, and then some code for your testing your wiring code. And similar is the case with my billing logger. I can pass a logger, and I can go and test whether that logger is logging the information correctly or not. It doesn't need to know about the caching. It doesn't need to know about my GeoSearch geocoder. And even in my GeoSearch geocoder, sorry, I forgot to mention that, I don't need to send real RPCs. I'm just checking my mock whether it tries to send an RPC or not. There is no network communication. Or even if you say that everything is in process, you don't need to bring another process of my GeoSearch so my geocoder can communicate with that for testing. One problem with this is now I need some wiring code to connect them. And I will talk about the wiring code later, but testing that wiring, for testing that wiring code, you can have an integration test. And that test is only responsible for the high level that, okay, does all these functions get called? That's it. It doesn't need to go and test the individual modules, all possible options. Okay, some more anti-patterns. One is that,
Just one question over there. So is it true, okay, if I have tested all, and I'm thinking logically, but I'm just trying to ask you from a practical perspective, okay, if I've done all unit tests properly, मैंने function लिखे और मैंने डेट प्रोडक्ट्स and conditional and test लिखे हैं, then when I integrate them together, there is never a need where I need to test multiple types of that. I mean, you just said I need to test one workflow where all of them are called. Is that really true?
No. So the thing is that it depends. So it depends on the fact, like, ideally that should be the case. But the problem is that sometimes the state moves from one state to another one. Or there are some interactions which are, some changes which are critical enough that you want to test them in integration test. So for them, you would like to have some integration test.
Any thought कि किस level पे करते हैं, मतलब कितने amount of integration test कितनी coverage देता है?
So ideally, your unit test should cover everything, every line of your code. And then the integration test is more about the interactions. And there will be code which you will like, okay, I need an integration test for this feature because it's such a complex feature, it goes through all these things. I don't need to test every corner case of that feature because my unit test will ensure that the coverage is there. But at least high level, whether it works like that or not. It can be like, for example, some synthetic workflow, maybe you send 5 requests and it should happen, this should happen, like kind of things like that.
So a follow-up question. Recently there is inclination towards using integration heavy testing, putting more weight in integration testing and putting less weight in unit testing. I mean, maybe you still have unit tests, but only for the critical pieces or critical units, and you write more and more integration tests. How do you trade off?
I don't know about that. I don't agree with that. The reason is that, as I mentioned earlier, like if you have 2 functions, and each of them has 3 options, and if you're doing unit test, you can test 3 options for function A, 3 options for function B. When you link them together, now you have 9 options. It's not 6. It's exponential. So now, is it possible to cover all those cases in integration test? The unit test gives you this feature where you have less number of tests to cover everything. And the other advantage of unit test is that they are fast.
You also distributed them down.
Yeah, and they're small enough that they're fast. In your integration test, you might have to bring some sub-process, so they can be slow. But your unit tests are really fast, or they should be fast. If they are not, you should make them fast. Your unit test should not take like order of seconds. It should be in milliseconds. Like you should not be writing huge classes that your test takes like order of minutes or seconds. It should be milliseconds. Did that answer your question?
Yeah.
It's my opinion, and I think I don't agree with that, so people might have other opinions. But I don't see especially for testing your system in integration test, I don't see a reason why will you do that, because it increases the number of tests to provide the same amount of coverage.
But what about applications, user-facing applications, where maybe your integration tests are more wired with your use cases, right? Your use cases are being tested through integration tests, and maybe you have less number of unit tests.
Like again, the point is the same, that you can have more integration tests. That is totally fine. But with unit tests, you need less number of tests to provide the same coverage. To cover all the corner cases, unit tests are better. Like with your integration test, you will not going to test like, oh, whether the string is empty or not. all those corner cases.
Okay. If we want to target surface area of coverage,
Yeah.
definitely you
Yeah.
can test that.
And every line in your code should be tested. Now there are tools for that, right? Which you can run and it tells you like, okay, this particular line is not tested.
Of course.
So, any other question? So here's another anti-pattern. You should not be creating your dependencies in your implementation. You should be passing them as an input. You should not be creating a cache inside your implementation. It should be an input. Similar is the case with your wrapper. If you pass them as an input, your code will be more flexible and your testing will be fast. You can replace them with mocks. Another thing is that you should not be passing the implementations of your interface. It should be interface. Like it should not be tied to that my cache accepts billing geocoder. It should be accepting the geocoder, and then I should be passing the geocoder instead of one specific implementation. So yeah, so I talked about the wiring code. Here's an example of wiring code. So what I'm doing here, I am passing my input parameters, which are geosearch, cache, and logger. I'm creating an object of new geosearch geocoder. Then I'm passing that and creating a caching geocoder and billing geocoder. So I'm stacking them together, and this is my geocoder now. If I want to go and look at the code, like what does my geocoder do, I can come here. And it will give me a high-level overview of my code. That, okay, this is the high-level overview. These are things get called, and this is what it should be doing. I would agree that the opinion is, it's debatable. Some people find it more easy to read such type of code. Others find the other type more easier. But in my opinion, it makes it slightly easier to read and understand the code. And it also helps you with the testing. And if your whole code is all set of these interfaces, you can go to all these files which are creating them and look at them, and it will give you an overview idea of what the function is doing. And then you can dig deeper to understand what's the underlying logic. Okay. So yeah, so that was all I have for interfaces. So ideally, I would say that your state should not. So now it depends. Like what are you passing? If you are storing some state, that should be local to a class, or in my opinion, it's preferred to be local to the class. So you don't need to worry about no locking. And if you are performing an operation on it, you can pass the output instead of like passing the whole object and modifying into multiple classes. It might be possible that there are some objects which you don't have any other option. You have to pass them around, but then make them thread safe and make sure it's clear where they're getting modified. But it's better if you isolate them. That will give you this nice layering where you can test them individually.
Yes.
Without like, okay, now these two layers or these two interfaces are linked with each other. Now, if they are linked with each other, does it mean that it should be one? Maybe your division is not correct. You are cutting it too narrow that now you have like these layers which are linked with each other. Maybe you might have to rethink that or refactor your code to have better boundaries in your code. So yeah, so I think I have a few more slides. So testing. So being able to change some random piece of code written by somebody else without grasping the entire context is really powerful. It can break a lot of things. And it can happen really easily. Especially like a Google-like environment where if we don't have testing, it's a single monolithic repository. So you can go and break anything. Yeah. So yeah. So yeah. But then again, there is a trade-off between the time you spend on writing tests and designing the code. If you design your code in such a way that it's more testable, you'll spend less time on testing. And then what else I have? Oh yeah, tests are the most precise specification of your code. If you want to understand somebody's code and you can't understand it from comments, the best place is to go and look at unit tests. It will tell you what it's doing. Your tests should be fast, and they should not be flaky. They should pass 10K to 100K times. My team is on this side, 100K times.
What do you mean 100K times?
If you run 100K times, it should not even fail once, a single test.
If they're supposed to succeed, because it happens.
No, I'm just trying to understand when you say 100K, मतलब unit test को मैं 100K तो फर्क.
Because some reason, some random thing, if it's flaking, it should not flake. If it's
Function which is doing something random,
or it's because of some dependency.
both parent. Is it unit?
So that's the thing. If you're writing it in such a way that if you're designing it in with those interfaces and everything is isolated, you can run them 100K times. If it's like involving all those other things, then you cannot run 100K times. So it will flake then. And the other thing is that it will become harder to even run them 100K time if it takes longer. To run them 100K time, it means that they need to be really fast.
And this is perfect. जैसे आगे में unit test normally तो मैं तो एक दफा run करके finish करता हूँ.
It might be because of some race condition, or you have threading. It's not like some threading issue. It can fail because of that. It's like the complex interaction,
This
like
is probably happening on the generation testing side more.
no, it can happen on if I'm writing a library and it should be a thread saved library, and I forgot one lock, and it's a race condition which happens once in a while, and it fails there. You should have good test coverage. If your test passes, there should be minimum output, but you should not like spam your whole screen with output or logs. And if it fails, then you should have useful enough output, so you can debug that. Mocks. So mocks are good for small tests. Some people think mocks are bad. It makes your system brittle or test brittle. If you look at there's a Google SWE book. It's available online. If you search SWE book, SWE book, you'll find it. It says that now we should not use mocks. It doesn't recommend mocks. And the reason, I think the main reason is, it's not that the mocks itself are bad. It's that if you use them incorrectly, it will make your test brittle and they will fail more frequently. And if your interface is one thing which makes it easier to use mocks, it provides that clean layering where you can pass a mock and test that system. So that's one advantage of using interfaces. You can use mocks. And even if you look at the original, the mock, I think there's a paper associated with the mock testing framework, mocking framework, is that the system needs to be designed like that. And one of the thing is that you should be designing based on what you want, not like testing what you want, not based on what is implemented there. And if that's the case, then in most of the cases, interfaces helps you with that, and your test will be fine. The one other thing which mock does, it isolates your modules, and you can just test that, okay, I expect 5 number of RPCs, whether I'm getting them in that order or not, and that's good enough to test. So it isolates from the side effects. Good mocks are enabled by good interfaces.
So, I have a question
Yeah.
on the last slide.
Yeah.
Previous.
Previous?
Yeah.
Yeah.
So when you're talking about 100K or 10K times running that function, is there any culture of where we can see the code being run in scalability, around the scalability of maybe 100 of users trying to run that code at the same time, and if it works, around stress, in the stress environment maybe. So do we actually run, maybe just trying to get the insights of your insights around that? Running the script one time and 100 times in serially and then in parallel?
No, the purpose of that script is not to test scalability of the
Yeah.
code. The purpose of that code, like, okay, indirectly you know that how much time that function takes, but the purpose is not that. The purpose is trying to figure out if there's any corner case where it can
So
fail.
the behavior might change for that function in maybe large number of users trying to.
That's a scalability problem.
Yeah.
That you will cover in your other test or other framework,
Okay,
other places.
Yep. So that would not be included while developing or integration testing or.
Not in like your unit test. I can talk about it more about it later.
Yeah. Sure.
So ask me later. So fakes also allows fast focus integration testing. With your fakes, your goal should be that they should have 0 startup time, minimum spam, log spam, 0 external dependencies, and they should be correct. And if you are creating some module or system, you should also be writing a fake for that. So in our case, the case of a geocoder, a fake would be a simple, like, if we want to implement a fake for a geocoder, which can be used by other people, it would be a simple hash map where you have some canned results like, okay, this address maps to this address maps to this coordinate, everything else is some error. So that can be a fake for that. And you can change your fake to pass more canned values. One last thing, your tests are not equal to your production code. Your test code is totally different from your production code. There are things which are acceptable in production code, but they are not acceptable. Like, they are not acceptable. They are not recommended in test. For example, in your production, you will try to have functions to minimize code repetition. But sometimes it's encouraged to have code repetition in your test because it makes it easier to understand the test. Here's an example. This example is from, I think it's a public example on Google's guideline, style guideline. We have a function to set up user, which add those users to a file. Then there is a function to register them, and then we verify whether they are registered or not. Look at this code, and then compare it with this one. Here, what we are doing is that doing the same thing. We are adding 2 users without a loop, registering both users, and then having an insert statement. This code is way easier to understand. Everything is in your view of sight, and you can read that code. Compared to this code, where you are using functions to write your test. So this is another thing which was interesting for me, that in test, it's usually encouraged to repeat the code as long as it makes it easier to read the code and understand the test. Software engineering is programming integrated over time. We talked about that. Interfaces are really useful, powerful tool for organizing software, and they help a lot with writing fake tests, and they help you test using testing with fakes and mocks. So that's all what I have. And if you have any questions, I would be happy to answer those.
One question on fakes. How do you write good mocks, especially with respect to, so that they don't maybe deprecate so often? Maybe you mock something?
Good mock or good fakes?
Good mock.
So mock is just like you have a class, and mock is expected function call to each of the functions. I didn't understand your question.
Sorry, must be about fakes.
Okay, yeah.
So
if you're modifying your code, you should also be modifying your fakes.
right, so they should always be generated through their interfaces.
Yeah, you can generate them through, but it will support the same interface. It should support the same interface, but you don't need to have everything there. Like, for example, in my geocoder, I just need it is implemented using the same interface, but I don't need my caching layer, my billing layer. I just need a single map, which is that, okay, this location maps to this coordinate, this location maps to this coordinate, everything else is an error, and I can have that fake for somebody else. I agree with you if you're pointing out that it's not always easy to write fakes. There will be complex systems where it's really hard to write fakes. In those cases, what you can do is if I'm depending on a complex system where there's no fake available, I can write a fake which is just for the required part, which I'm using. I don't need to write the fake for the whole thing. As long as your fake is correct, it should be fine. But if you modify your functionality or change your logic, you have to update. A fake is part of your code. It should live with your code. It's not like, okay, I have modified this, you should also update to fakes.
I have one question around that. So I think fake से मुराद ये बनती है ना कि जो चीज़ हमने पीछे interact कर रहे हैं, database है, एक model है, उसमें क्या चीज़ें आ रही हैं. This becomes complicated, and Faraz, you remember this, जब हम Kafka शाफका से अगर interact कर रहे हैं, कोई और message, कोई और system हो जिससे आपने चीज़ें लानी होती है, then even just the type of data that you get could vary a lot, right? And for each one of them, the system has a different response. So faking that becomes a lot of thinking. And you're right, it could change just because आपने कोई और चीज़ कहीं और पे की, and now you have another type of message that could come out. And now you have to react to it differently, so you need to test it. So there's a lot of thought over there.
Yeah.
इसको कुछ simplify करने का तरीका है कि बस just you need to be on top of it.
No, like I don't think like there's like some one thing which can fit all of that. But the thing is that like if you are test, you have Kafka, you don't need the whole Kafka, right? Yeah. So it will add more.
That's something you have to fake.
Ideally, the team who is writing that code should provide a fake. Ideally, that should be the case. That's why I said like, okay, if I am implementing geocoder, I will be providing the fake and how I will provide that fake. If they are not providing the fake, now there's a trade-off whether you want to depend on that slow dependency or you want to implement your own. So then it's like, okay, I can implement my own, I can do this amount of testing with that, and for this testing, I will use the real system.
If we implement, okay, so if we implement our own fake, how would we ensure that it gets updated whenever?
Then you have to, you are responsible for that.
Yeah, so I mean, are there any tips or tricks to make sure we track it better somehow?
You can link it with their testing, or have tests which, yeah, I think that would be the best one. Like you can, yeah, I think that would be the case. Or it's like, okay, my fake is passing a test, but my real production system is not. Now there's something broken. I need to go and fix it. It might be it's opposite. The fake was right. Fake was right.
That's the risk of using fakes, actually.
No, it might be true that your fake is giving you right output because it was a canned output, but there's a bug in the real system, so you have to go and fix the real system.
Yeah. Large enough systems require this. And छोटे systems की value नहीं बनती है. It's only when you get large systems that this becomes. You cannot catch it yourself. One person cannot catch it. So then you need these abstractions.
But the problem with also the large system is that it also becomes hard to write fakes. Those systems are so complex that like writing a fake for big table would be like really hard. You can write fakes for the part of big table, but not for the whole.
And how would you go about it if it's a third-party dependency, right? Maybe an external library or something.
So here the advantage of using fake is that you are making your test faster.
Yeah.
So if you don't have fake, your test will be slow.
Yeah.
Now what you can do is like you have some test which depends on the fake, and you are using your third party is not providing you the fake. You have implemented it, but you have make all those tests faster. If you are making 90% of your tests faster, you only have now 10% which depends on the real system.
That makes sense.
So there will be a lot of part of the coverage in the code where you don't need that complex system. For some part of the code, you need a complex system, you will bring that up, and you can't do anything else there. But in a lot of part of the code where you don't need the real system, you just need some input because you are testing your part of the code. So for that, you can still use the fake. It should be correct, but it doesn't need to implement the whole thing.
So I have two questions actually. You said software engineering is integrated over time. So I would like to know.
It's programming integrated over time.
Programming integrated over time, yeah. So I would like to know how you or Google is solving that problem. So thing here at usually in all the sort of small local startups is that we have this prototyping and we tend to sort of enhance that prototype into a production code. So how would you suggest to solve this problem, or how actually Google is solving this problem?
So-
the other question is, so
No, go ahead. Go ahead.
So the other question is, okay, you can answer first, and
Okay, you can take
because
the
that
second
is
one.
entirely
So,
different.
so yeah, so that problem can also exist in Google. It might possible that I write some script just for some analysis, and it's like for my own analysis. It lives on that side of spectrum. I thought that the lifespan of that script will be a few weeks. And I did not plan it for the other side because I can't see the future. It might possible with time, it changed, and now it becomes my 20% project where other people are using it, and maybe later it becomes a full project. It can transition to those stages. Then if it's transitioning, at some point I have to decide that, okay, I have to refactor my code. I have to design it with the new requirement in mind and have that code. So the idea is like, don't be scared of deleting code or modifying code. That's our job, like refactoring and changing code and making it easier and faster. Does that answer your question, or maybe I missed your question?
Sort of, yeah. it
Okay.
is. So the second question was, so there is already a culture in place in Google regarding testing and writing unit tests. How would you suggest a small startup which do not have any such thing in place? They are mostly focused on the deliverability side, sort of faster prototyping and fast delivery lines. So how would you suggest, or where would they start to sort of start writing this unit testing, start developing that habit of writing unit testing?
I think it's like it has your manager, your team lead needs to be on board. You can't do it without that. And then it's like whenever you're writing your code, you should be writing tests with that. Usually it takes me more time to write the test than my actual code. So it takes time because if you need the whole coverage, it takes time. It slows you down. So now it's all you need to be on board with your manager, like how much we can invest in it. It's really good to invest because the future you will always thank the past one. Oh, yeah. so that's why you have to talk with them, and ideally, ideally it should be known to everybody. Like they should be open to the idea that okay, this is important. We need to have time for testing in our. How can you deliver a project without testing? Even if there's a time crunch, how can you deliver? Like, what if those features doesn't work? You need some testing.
सर्विस बेस्ड कंपनीज जितनी भी होती हैं उसमें ऑफ कोर्स इनोवेशन साइड जो है उस पर हम काम कर रहे होते हैं. वलीद जो क्वेश्चन पूछ रहे थे उससे रिलेट ही कर रहे हैं. हम MVPs पे फोकस कर रहे होते हैं, फास्टर इनोवेशन एंड टाइम टू मार्केट एंड ऑल दोज थिंग्स. वी डू दैट. उसमें हम जल्दी जल्दी बना भी देते हैं, चीज़ें दिख भी जाती हैं, चल भी रही होती हैं टू एन एक्सटेंड. Then client pressures and all those things come into play, and we say, oh, this is something that seems to be working. Let's go towards the production side. Let's start working. Of course, productization and all those things, they take a lot of time. But then what is the bare minimum when we talk about MVPs? Then we say, yes, this needs to be a part of MVP, even if you are talking about the MVP, because later on it can transition, it may transition, and most of the time it does transition towards the production side of things. So what the bare minimum that we need to capture, be it the managers or leads sitting together and suggesting, okay, this needs to be a part of it, but what's the bare minimum that needs to be a part of the MVP even?
In terms of testing?
Yes, absolutely. Because usually we ignore it completely
So
with respect to time.
I think you should have like the basic test coverage should be there. So that should be the bare minimum which should be in place. Because it's not like, the problem is like when your system becomes too complex, it becomes really hard. So my PhD is in systems. I have written a lot of code there, and without testing. And I know how that used to work. Like if I used to go back after a month and some parameter changed, something changed, and now it's not working, I don't know why is it not working. My end-to-end system used to work, now it doesn't work. And now what I used to do was like, okay, now put print statement and find like which part of the code is not working. It might be possible that some library has changed, and because of that, my code is not working now. So I have done that. So that's why I'm telling you, like, these are the things which I started admiring after joining Google. That, okay, if I have to do my PhD again, it's the same thing that I have to talk with my advisor. Talking with the advisor is hard. Convincing an advisor for testing is harder than convincing a manager. Yeah, exactly. There the goal is to just produce a paper.
And if we have messed up, let's say we have messed up, we didn't write anything, just like you, just like you. Now the things are getting towards the production, right? And that's where you do the negotiation again. Yes, it has to be there before we go into there.
Yeah. Like, what's the other option? Do it after production? So at some point you have to do it. Wherever you realize that, okay, I need this, you have to do that. Maybe I'm missing what you guys have done. So that's why I don't have the context.
I need to switch it off.
What has happened? Okay, sure.
Just to put that in a different way. So trade-off होता है ना, right? Time का trade-off है. It's all but there's a trade-off in time.
Okay.
कि आप testing कितनी coverage लिखते हो और and then there is work to actually show features and features are what people will buy and all of that. So there is a trade-off over there for sure. I think मारे का जो question था वो इस तरह था कि अगर हमने किस complexity level, let's frame it different way, किस complexity level पे you have to start arguing कि नहीं मेरी coverage इससे ज़्यादा होनी चाहिए. मतलब let's say we're doing some very basic functional testing of the system from the start. I think वो तो हम अभी भी करते हैं, हमारी testing functional हो रही होती है या ऐसा कोई नहीं होता scenario. या आप कोई चीज़ release करते हैं तो उसके जो functional हमने समझे चीज़ वो test नहीं हो. Refactor your code to have unit tests in them and also start building their code with unit tests. So in a maturity model from your experience, when would that influx or when would that inflection point make sense?
Okay, so I don't have the right answer for that. And the reason is that my only proper long full-time job is Google. I have not worked, before that I have worked at few places, but the proper full-time job, this is my first job. So I don't have the experience of that side of the world. I have some, but I would not talk about that on the camera. So the thing is that it's your call. You have to decide like, okay, at this point I need some basic unit test, and I don't have enough time to have all of them. I don't have all the coverage, but at this point my project is becoming complex enough that I should add more tests and then move forward. It's becoming a mature enough project that I need a better coverage, and before doing something new, I need testing for the previous one. So at some point, you have to call that. It's your call. You have to decide based on the complexity of your software. I don't think there's any rule of thumb that, okay, if your lines of code is more than this, you need testing. If it's less than this, you don't need testing. It's more like the complexity where you think that, okay, because again, it's the but it's a trade-off which you are doing even from the start, that I don't have enough time for testing. Ideally, you should have time for testing and you should be writing those tests. But later you are like, okay, now it's becoming complex. The tests are becoming more critical. It started breaking more. So it's like I don't think there's a rule for that. Like, okay, the rule is start writing tests from the day one. That's the rule. But that is not. I understand that's not possible when you have time crunch. So I don't have a better answer for that.
So I have another question, follow-up question. So, do you happen to know consequences of unit testing after developing the project? Because maybe if we, some of the leads here, PMs, if we get to know about the consequences of doing that, maybe it will help us put our foot down before developing the project that we need to have this, right?